Every mammal on Earth drinks milk. A kitten drinks it. A puppy drinks it. A leon. Cub. A chimpanzee. A calf standing under its own mother. Milk is the first food any of us ever gets. Then every single one of them quits. There is a switch in the gut that handles milk sugar. And in nearly every mammal alive, that switch gets turned down after weaning. It is not damage. It is scheduling. Milk is baby food. And the body closes the factory once the baby is done. There is a second rule. And this one is harder to break. No adult mammal in the wild goes looking for milk from another species. A wolf does not milk a deer. A chimpanzee does not milk anything. The idea does not exist out there. One animal breaks both rules. Around 9,000 years ago, in what is now Turkey, people started pulling milk out of another animal and pouring it into a clay pot. Not from a human mother, from a cow. And the wording matters here. So let me be exact about it. Humans have been drinking human milk for as long as there have been humans. That is not the story. The story is animal milk. Moving into the food supply of a species with no equipment for it. Because here is the part that stops you cold. The people who started this almost certainly could not properly digest what they were drinking. So, how do we know any of it happened when the liquid itself evaporated 90 centuries ago? And why did they keep at it for 4,000 years before their own bodies caught up? Milk is a liquid. Liquids do not fossilize. There are no recipes from 9,000 years ago. Nobody painted a picture of a woman milking a goat. There are no account books and no letters. Because writing had not been invented anywhere on Earth yet. Whatever these people did, they did it. And then they walked away. And the whole thing should have vanished. What they left behind was pots. Neolithic pottery has no glaze on it. You fire the clay, and you get a wall full of tiny open pores. And those pores behave exactly how you would guess. Cook in the pot, and grease works into the wall. Wash it, and the grease stays. Fill it 1,000 more times over 20 years, and more grease goes in. You already know how this works. Pull a plastic container out of your cabinet, one that has been through the dishwasher 50 times. And it still smells faintly like the chili you made last winter. Same physics. The only difference is that fired clay holds onto it for 90 centuries instead of 6 months. For decades, that was a curiosity and nothing more. Because fat is fat. A greasy pot tells you somebody cooked. It does not tell you what. Then chemists found the crack in that problem. Animals do not build all their fat the same way. The fat packed around muscle and organs gets assembled differently than the fat a mother produces in her udder. And the two carry slightly different ratios of carbon isotopes. Measure those ratios in the two main fatty acids soaked into a potsherd and you get a fingerprint. One fingerprint means the pot handled meat. The other means the pot handled milk. So, an empty piece of broken pottery, sitting in a drawer in a museum. I can tell you whether it cooked a sheep or held that sheep's milk. In 2008, a team led by Richard Evershed at the University of Bristol ran that test at scale. More than 2,200 pottery fragments, pulled from sites across the Near East and Southeastern Europe, covering 3,000 years of the Neolithic. They wanted to settle where dairying actually started, and whether it began in the same place farming did. The oldest milk signatures came back from the 7th millennium before Christ, roughly 9,000 years ago, and they clustered hard in one place, northwestern Anatolia, where the land and the climate suited cattle better than anywhere else in the sample. So picture a morning there, somebody holding an animal steady, somebody else with a clay vessel, warm milk going into fired earth. In a village with no writing, No metal, and no wheel. Now, let go of that picture, because we did not find it. We found grease in a broken wall. The scene is a reconstruction, and it belongs to you and me, not to the evidence. What the evidence does deliver is stranger than the scene anyway. At a site called Bargın in northwestern Turkey, researchers went through hundreds of Neolithic sherds and found milk residues sitting in the very earliest pottery at the site, not in the upper layers, where you would expect a new practice to show up after people settled in and figured things out. In the first pots these farmers ever made there, which means they did not invent dairying at Bargın. They showed up already knowing how to do it. That is worth a second. 9,000 years ago is not the moment humans worked out that a cow could be milked. 9,000 years ago is the oldest surviving receipt. Archaeology gives you the earliest evidence that happened to survive, and nothing more than that. Nobody is ever going to dig up the first cup. There is also a limit built into every single one of these pots, and it is going to reshape this entire story before we are done. A pot proves milk was in the village. It says nothing about anybody swallowing it. For that, you need something worse than broken pottery. You need the teeth. Twice a year, somebody in a mask scrapes hardened plaque off your molars, drops it in a suction tube, and throws it out. That material is one of the best archives in archaeology. Dental calculus is plaque that mineralized in place. It turns to stone on the tooth while you are still alive. And it seals in whatever was floating around your mouth at the moment it hardened. Bacteria, pollen, starch grains, and protein fragments from food. Teeth survive even better, and the crust on those teeth survives right along with them, which means a person who died 6,000 years ago can still be carrying a sealed record of what they ate. The protein researchers go looking for is called beta-lactoglobulin. It is a whey protein, and it shows up in one substance: milk. It does not occur anywhere else in the human body, and it does not come from anything else on the menu. Find it welded into somebody's plaque, and that person had dairy in their mouth. Then it gets sharper. Buried in one commonly recovered fragment of that protein is a single position where the amino acid changes depending on which animal produced the milk. One letter for cattle, a different letter for sheep, a different one again for goats. One letter, in one molecule, stuck in the plaque of somebody who has been dead for thousands of years, and it tells you which animal they were milking. That is a different order of evidence than a greasy pot. And the jump is worth spelling out. Residue in pottery tells you milk was being handled somewhere in a settlement. It could have been processed by 3 families out of 40. It could have been fed only to children, or only to the sick, or only to dogs. The pot cannot say. Calculus tells you it went into a specific human being. Somebody with an excavation number, a skeleton, an estimated age, an estimated sex, and a grave. Which brings up something that gets flattened constantly online. And getting it wrong will wreck everything that follows. There are 3 separate claims here, and they are not the same claim. Dairying means milk was collected and processed. That is what the pots prove. Dairy consumption means somebody ate or drank a product made from milk. That is what the teeth prove. Drinking fresh milk means exactly what it sounds like: a cup of raw liquid, straight from the animal, going down an adult throat. Nothing we have covered so far proves that at all. And the gap between the second claim and the third one is where this entire story turns. A pot loaded with milk fat could have held yogurt. It could have held soured curds, or butter, or something halfway to cheese, or milk that had been sitting out in the sun for a day and a half and had already started changing into something else on its own. So we know milk was in their mouths. We know which animals it came from. We also know something about those people that makes the whole arrangement look impossible. Almost none of them had the gene. Walk down the dairy aisle at any American grocery store, and you will find a whole shelf built around a problem. Lactose-free milk. Ultra-filtered milk. A row of pills near the pharmacy counter that you swallow before pizza so you can get through the night. Everything about that shelf says the same thing. Something is wrong with you. And here is the fix. Now here are the actual numbers. Roughly 65% of people on Earth lose most of their lactase after infancy. In communities of East Asian descent, that figure runs anywhere from 70% to 100%. Across the whole species, handling milk sugar as an adult is the exception. And it always has been. That is the factory closing on schedule. Exactly the way it closes, in a kitten and a lion cub and a calf. So the shelf has it backwards. There is a group of people walking around with an unusual variant in their DNA. A rewrite of the instructions that tell the gut when to shut the enzyme down. If you can drink a cold glass of milk on an empty stomach and feel nothing at all, you are in that group. Among people of Northern European descent, only about 5% are lactase non-persistent. If milk goes down easy for you, you are the strange one in this story, not the guy with the pills. Which brings us to the problem sitting underneath everything we have covered so far. Ancient DNA can find that variant. Researchers have pulled it out of skeletons across Europe and tracked how common it was. Century by century. The oldest known appearance is around 6,700 years ago in Central Europe. It turns up here and there around 6,000 years ago, in a handful of individuals, and then it mostly sits there. It does not become common until the late Bronze Age, thousands of years later. Put the two timelines next to each other. Milk was in clay pots in Anatolia 9,000 years ago. Milk protein was locked in human dental plaque long before the gene showed up in any meaningful numbers. Farmers across Europe were milking cattle, sheep, and goats for 40 centuries, while most of the adults among them were paying for it afterward. Which raises a fair question. Why would anybody keep doing that? They kept doing it because they fixed the food instead. In the 1970s, archaeologists working early Neolithic sites in Poland kept pulling up the same odd artifact. Fragments of pottery punched full of small holes. Somebody had made a vessel and then deliberately perforated the walls. For decades, these got labeled cheese strainers, purely because they look like cheese strainers. Nobody could prove it. In 2012, Evershed's group ran the same lipid chemistry on them that had worked on the Anatolian pots. The perforated sherds came back loaded with milk fat, far richer in it than the ordinary cooking pots from the same villages. Those objects were straining dairy, 7,500 years ago. Here is why that matters more than it sounds. Lactose is a sugar, and sugar dissolves in water. When milk separates into solid curd and liquid whey, most of the lactose rides out with the whey and goes down the drain. Fermentation takes care of a good chunk of what stays behind, because the bacteria doing the fermenting eat it. What you are left with is a solid that keeps for weeks instead of hours, travels on a person's back, and carries a fraction of the milk sugar you started with. So picture a woman pouring soured milk into a clay vessel full of holes, whey running through, hitting the ground. Something thick and pale left sitting inside. She is operating a lactose removal device. She has never heard the word lactose, and nobody on the planet has any idea that sugars exist. I want to be careful with what I claim here. Do not read that scene as the invention of cheese. And do not assume anybody made it to solve a digestive problem. Milk spoils in half a day in a warm climate with no refrigeration. and a solid you can carry is worth having, whether or not it upsets your stomach. Preservation, transport, and flavor are all live explanations. What we can say is that the principle was already running, thousands of years before the gene arrived. And if you want to see how far that principle goes on its own, go to Mongolia. In 2018, a team including Christina Warner published work on 22 late Bronze Age burials from the Khuvsgul region in northern Mongolia, dated between roughly 1380 and 975 before Christ. They scraped dental calculus from 9 of those individuals. 7 came back positive for milk proteins from cattle, sheep, and goats. Then they read the genomes. Not one person in that cemetery carried lactase persistence. Not a low frequency. 0. These were herders descended almost entirely from local hunter-gatherers, who had picked up the practice from their neighbors without picking up the biology. Their descendants went on to build one of the most dairy-dependent food cultures on Earth. Fermented mare's milk, dried curd, milk vodka. There is ongoing research into whether gut bacteria take on part of the digestive work in populations like this. And it is a promising line, though it is not settled. Now go about 1,000 miles southwest, into one of the driest places on the planet. The Taklamakan Desert in western China preserves the dead the way almost nowhere else does. No moisture. No rot. Archaeologists working a cemetery called Shaohe opened coffins shaped like boats. And inside were people from the Bronze Age with their eyelashes still in place. You can see hair color. You can see the weave of their clothing. Faces that should have been gone 3,000 years ago are still faces. And on some of them, scattered across the neck and the chest, were small white lumps. Nobody knew what they were. They stayed unidentified for about 20 years. There were guesses. Some kind of powder. Some kind of offering. A cosmetic. Maybe. Or a ritual paste smeared on the dead before burial. The material was there in the collection, catalogued, sitting in storage, and it did not match anything anybody could name. In 2024, a team led by Xiaomei Fu at the Chinese Academy of Sciences pulled DNA out of the lumps. It was cheese. Kefir cheese. 3,600 years old. The oldest cheese ever physically preserved. The DNA showed cow and goat, kept in separate batches instead of mixed together, which tells you somebody had a method and stuck to it. And still readable inside that material were the ancestors of the same bacteria and yeast that ferment kefir in a grocery store cooler today. They went into the ground wearing the answer, which leaves one thing unexplained. If culture had already solved the problem, why did biology go to the trouble of solving it a second time? For most of the last half-century, that question had a clean answer. And it was in every textbook. The story went like this. People domesticate cattle. Milk becomes available year-round. Anybody born with a variant that keeps the enzyme running gets calories, protein, fat, and clean fluid out of that milk, while everybody else gets a stomachache. Those people are a little healthier and raise a few more children. The variant spreads. More milk drinkers means more dairying, which means more pressure, which means more milk drinkers. A lope, feeding itself, running for thousands of years. It is elegant and it makes intuitive sense. And there was real reason to believe it. Lactase persistence is the most strongly selected single gene trait humans have evolved in the past 10,000 years. Something pushed on it hard. Milk was the obvious candidate, because milk was right there. The trouble is that nobody had ever actually measured the two things against each other. In 2022, A group led by Richard Evershed at Bristol and Mark Thomas at University College London did exactly that. They assembled about 7,000 pottery fat residues from more than 550 archaeological sites, covering 9,000 years, and built a map of how much milk was being used across Europe through time and space. Then they lined it up against ancient DNA showing where and when the gene was actually spreading. The two maps did not match. Regions with heavy dairying did not reliably produce the gene. Regions where the gene took off were not the regions drinking the most milk. When the team compared explanatory models, the amount of milk people used turned out to be a worse predictor of selection than three other things entirely: population crashes and rebounds, how densely people were packed into settlements, how much they were still hunting wild animals. Read that again, because it is the whole hinge. The thing everyone assumed was the cause showed no useful correlation with the effect. So, what does explain it? The team's proposal is uncomfortable, and it turns on a distinction most of us never have to think about. If you are healthy and lactose intolerant and you drink a glass of milk, you feel awful for a few hours. You bloat. You cramp. You spend some time in the bathroom. Nobody dies. That is true for hundreds of millions of adults today who drink milk anyway and simply accept the cost. Change the conditions, and that arithmetic changes completely. Now it is a bad year. The barley failed. The stores ran out in February. And the herd is the only food left standing. You are already malnourished. Milk is no longer a beverage. It is the entire diet. And the diarrhea that was an inconvenience last summer is now pulling water and salts out of a body that has nothing left to spare. Or the crop is fine, and the problem is the village itself. People living on top of each other. Animals inside the settlement walls. Waste everywhere. Disease moving between livestock and humans. You are already fighting an infection in your gut. And the milk makes it worse. Under those conditions, the person who can process lactose is not slightly better fed than her neighbor. She survives a winter that kills him. That reframes what selection even looked like. It was not a gentle 4,000-year climb driven by people enjoying dairy. It was quiet for long stretches, then brutal in the bad years. Famine and epidemic did the sorting, in bursts. And the gene climbed on the backs of those disasters. The variant did not spread because milk was good for people. It spread because the people who lacked it died during the worst years. And milk was what made the difference. Now, how confident should you be in that? It is the strongest explanation currently on the table. And it came out of the largest dataset ever assembled on the question. It is also a proposal. And some researchers have pushed back on it. The main objection is about the proxies. Population fluctuations and settlement density are stand-ins for famine and disease. And a stand-in is not the thing itself. Whether those measures really track hunger and pathogen exposure across 9,000 years is a fair fight, and it is still being fought. There is a second limit worth stating plainly. All of that data is European. Lactase persistence also evolved independently in parts of Africa and the Middle East. Through different mutations in different populations who never met, nobody yet has enough pottery residue or ancient DNA from those regions to run the same test. So the old answer is gone, and the new one is a hypothesis with real evidence behind it and real questions in front of it. 3 objects. A broken piece of clay from a Turkish village, with animal fat worked into its pores 9,000 years ago and still sitting there. A crust of hardened plaque on the teeth of a herder buried in northern Mongolia, holding fragments of protein from a goat that died 3,000 years ago. And 1 letter. Changed. In a stretch of DNA that most of the people in this story did not carry. Those three things are the whole case. And together, they give an answer that comes in two parts. When did ancient humans start drinking milk? Around 9,000 years ago. They were milking animals and processing what they got. And that is as far back as the surviving evidence reaches. When did their bodies become able to handle it without paying for it? Thousands of years after that. And in most of the world. Never. So they did it the hard way first. They strained it, soured it, fermented it, packed it into curd, and carried it across a desert. All of it worked out by people who had no idea what lactose was and no gene to help them. Humans did not start drinking milk because evolution allowed it. Evolution caught up because they refused to stop.